9, 10, 11 properties. Okay, for logs. For example, I will choose few properties here. Let's say the first one is about logs. The first properties is about the addition properties log for between m and n. The first property like this. Okay, let's say please refer to section 1.10.2, page 47, properties of log. Okay, I will explain the with example. Let's say okay, let's say the first property is about the, let's say we have logs b m times n. This equal to logs b m times logs b n. In other words, we have a multiplication of m and n. We can divide this into 2 logs bm plus log m. Let's say, for example, logs, let's say logs base 10 of 8 times 7, for example. Let's say we have this log. Okay, this log can be divided into the logs logs 8 plus log 7. This is the property of the log. Okay, you can use your calculator to find the logs. Okay, I hope you know how uh, uh, to use your calculator because there are log button here. You just click log 8 plus log 7. Okay, the answer is 1.7482. That is the properties of log. The property number 1. Okay, the second one, if log for ratio, let's say we have log bm divided by n. Now m bagi n, m divided by n. Okay, this equal to log bm minus log bn. That is the relationship for the logs b logs b divided by m. For example, let's say given logs 9/2, okay, this equal to log 9 minus log 2. And again, the answer is just use your calculators. That's why you need for this operation you need a scientific calculator. This equal to 0.6532. That is the operation for log 9 divided by 2. Okay, the next one, let's say log, okay, log with power. Okay, let's say this is this way also this is important. Logs b m to the power of n. In this case, if we have the log of base b of m, base to the power, we have m to the power of n is also equal to the log is equal to n times log b of m. Okay, that's the how to find how to find the solution in case we have this log. For example, we have log b m log b of m to the power of n equal to n times log bm. Okay, in this case, I just want to explain that when we take the log of a number, let's say m with an exponent m to the power of n. Okay, this m as a power of n. In this case, m with the power of n. We can bring the exponent down in front of the log as a multiplier. For example, m is the power of n. uh, this exponent, this n, we can bring this exponent and then bring the exponent down and put in front of the log as a multiplier. In other words, the power the power in the equation now become multiplier in front of the log. We just just bring the power, the exponent down, and put in front of the log as the multiplier. For example, let's say I have we have which one? Okay, logs. Let's say log 8 to the power of 2. Okay, this is equal to 2 times log 8. The 2 is power. 2 is the power. We can bring down the power and then put the power in front of the log as a multiplier. We just write 2 times log 8. That's how to apply the properties of log, or property number 3 in term of this log. Okay, that's for for another example. Let's say I have this log. Let's say log x to the power of 3. Okay, this equal to 3 times log x. We can bring down, we just put this power and then put as a multiplier in front of the log. That's the relationship between the properties of the log with when x as a power. Okay, the next one is about the, let's say, how to change the base, the base, the b, the value of b. Let's say, please refer to properties. I just move to properties number. Okay, before that, properties number. Okay, number 6. Logs b of b equal 1. Logs b of b equal 1. In this case, b equal x. The value of b equal x. For example, let's say we have log, this one, log 10. Log 10 is a log with base 10 of 10. The answer is 1. Log 2 of 2 is also equal 1. Log e of e also equal 1. That's the relationship between when b equal to x. The base and the value of b and the value of x is equal. The answer is always 1. And then the logs for log 1, for any value of b, it doesn't matter what value of b, is always equal. That's always equal 0. And then okay, how to change the base, the value the base of the log. Let's say I have this log with base b, logs b of m. Now I would like to change the base into the log a. Okay, the log a. I just want to change. Let's say we want to change b, the base b, the value of b from b to a. Okay, the formula is you refer to the properties of log on page 47. Okay, this is equal to log a m, log base a of m divided by log a of b. That is the formula. For example, let's say I have given log 2 of 7. Okay, now I would like to change to the log 10, log 10, or common log. This is equal to log 10 of 7 divided by log 10 of 2. Or another example, let's say we have log 3 of let's say 4. We like to change to the ln. This is equal to ln 4 divided by ln 3. We will get the same answer. Okay, that's the uh, some properties of the log. We can uh, we need all the property is very important. We will apply. We need this property, especially uh, in the next topic, for, especially for topic 2, topic 3, and so on. Sometimes, in order to find the answer, to find the solution, we need this property, whether there's a log property of log or property of exponent. Is depend on the question and the information that we have in the question. Okay, that's about the property of log. Okay, look into to the few example. Please turn to the page 48. There are few example here. Please refer to page 48. There are few example. I will show you. Let's say look into the example 1.41. Example 1.41. In this example 1.41, let's say the question is simplify ln e to the power of 3x. Simplify ln e to the power of 3x. We need to simplify. Pemudahkan. Okay. ln e to the power of 3x. Okay, we have ln e to the power of 3x. Since this equation is a log, is in log, we can we have the power e to the power of 3x. We can bring this exponent, this power down and put in front of the log. This is equal to 3x, sorry, 3x ln e. 3x ln e. Again, what is ln e? Okay, I hope you can remember this. What is ln e? ln e is a log e of e. So in this case, if you refer to the properties of log, I think properties number 6. Okay, the base and the x is equal. B equal to x. Okay, this value is equal 1. So 3x times 1 is equal 3x. That is the answer. Because the ln e is equal 1. Okay, that's example 1.4. Okay, the next example, please refer to the example 1.42. 1.42. Let's say we have this 10 to the power of, let's say 10 to the power of log x squared minus 25. Okay, the question is find x. What is x? Calculate x. We need to find what x. And x is a power in the equation. Okay, so in order to find the answer, okay, there are a few ways to solve this equation. Okay, I will show you by using the concept of log. Let's say, for example, okay, in order to find this, to find x, we need to make sure the x we can bring the log the power of the equation down, and then we make it as a multiplier. For example, let's say to find x, okay, based on this equation, okay, first we can we can convert all the equation into logs. For example, let's say I choose the left hand side. I convert this equation into logs. Let's say log base 10 of 10 to the power of log x squared equal to log 25. Okay, we can change the exponent, this exponent into the log. So now we have log 10 to the power of log x squared minus log 25. Okay, now we have this power based on the log properties. We can bring down this power. As you can see from the previous example, we can bring this power down and put it in front of the equation as a multiplier. So this is now log x squared. That is this is the power times log 10 equal to log 25. Now we have log x squared times log 10 equal to log 25. Okay, this log, this we have a log property here. This is a log 10 of 10. The answer is 1. So now this equal to log x squared minus log 25. Log x squared equal to log 25. So since we have same both equation now have a log with the same base, so we can slash this log. So this equal to x squared minus 25. So based on the mathematical, now we know x squared equal to 25, x equal to the square root of 25, and then the answer is 5. Of course, 5 times 5 is 20, is 25. But please remember that since there is a positive value of 5, times positive value of 5 is 25. We also have a negative 5 times negative 5 is also positive 25. So the answer is we need to write x equal to plus minus. In other words, there are two values to answer here, x equal 5 and x equal negative 5. Because when we're talking about the square root, we need to multiply two numbers. Square root meaning that, let's say, square root of 25 is equal to 5 times 5. And at the other part, we also have negative 5 times negative 5. The answer is also 25. That's why the right answer is x equal to plus minus 25. Okay, that's one of the example. The next one also on page 48. Please refer to the example 1.42b. 1.24b. Okay, let's see example 1.42b. Sorry, 42, not b, 42d. 1.42d. Okay, the question is given log 2x equal to 5 minus log 2x plus 4. That's the question. So find x. Same question. What is x? Find x. What is x? So in order to find x, we need to rearrange the equation. We just put all the log at the one side and the rest at the other side. So we have here, let's say I arrange like this: log 2x plus log 2x plus 4 equal 5. I just arrange the part of the equation with log at the left hand side, and the rest we just put it the coefficient or the equation at the right hand side. Okay, now we have this equation log 2x plus log 2. Okay, now these two part has they have a same base here. Now we can apply the rule of the properties of log, or rule of log. So based on the rule of log, we know that if we have these two log with the same base, same value of b, this equation can be simplified as a log 2 x, the first time x plus 4 equal 5. Okay, that is a log base 2 of x times x plus 4. Okay, now based on this, we need to find x. Okay, remember, I hope you still remember here. Okay, this is a log. We have if y equal to log bx, so x equal to b to the power of y. Okay, we have this is y, this is b, this is x. Okay, y equal to 5, b equal to x equal to x plus 4. So based on this rule, you can write the exponential function of this log. This equal to x plus 4 equal to b to the power of y, 2 to the power of 5. Okay, this equal to x squared plus 4x. This equal to 2 to the power of 5. This 32. 2 to the power of 5 is equal 32. And then okay, now we need to find what is x. Okay, since this okay, I hope you still remember this is a quadratic. Okay, we can arrange the equation x as a quadratic function. Now we have quadratic problem here. X2 plus 4x minus 32 equal 0. This is a quadratic where a equal to 1, b equal to 4, c equal to negative 32. Use the if you refer to page 49. Okay, now in this case we have the quadratic equation here. So we how to find x? We need to apply the quadratic formula. Okay, just use a quadratic formula. So what is the quadratic formula? Okay, negative b plus minus b squared minus 4ac square root of divide by 2a. Okay, based on this formula, you will get the answer is 4 and negative 8. That is for x. For the answer, you can refer to page 49. Okay, as you can see here for the example, in order to find to solve the log equation, we need the other information, the other formula, the other information. For example, the quadratic information, the quadratic formula, in order to find the value of x. So in this case, show that the relationship between all the function. Sometimes we need the concept. We need to apply the concept of quadratic, log, exponent, or linear. For the let's say for the one question. Let's say we have one question, but that one question in order to find x or y, sometimes we need to apply to apply the other concepts. For example, the quadratic or linear to find that in order to find the value of x. That's why be careful when you want to solve the any question. Make sure you know how to choose the formula, how to choose the right formula. Okay, that's the some of the example. I hope you can do your revision, and then please try to answer all the others question. There are few example here: 1.39, 1.40, 41, 42, and so on. Okay, that's about the example on page 49. Okay, the next one is about the how about the graph of the log function. As I said earlier, the log is the inverse for exponential. So we can conclude, we can imagine here that the graph of log is an inverse for the graph of exponential. As you can see here, based on the properties of log, the function of y there are few characteristic, few property of the graph for logs. uh, uh, where the log function is y equal to log bx. Again, b must be positive, greater than 0, and b must not equal 1. It same goes to the exponent. The first one, the first properties of the first property is about the domain. The domain is about x. For logs, the domain of any log is positive, from positive to negative infinity. That is, thus the log of non-positive number does not exist. The value of x must be positive, 0, and x must be greater than 0. That's the value for value for uh, value uh, for x. The domain is refer to x. Okay. The range of any log. Okay, the range. What is the range? The range means that the y, the value of y can take any value from negative infinity until positive infinity. Y can be positive and negative, but x must be positive. The log of 1 is 0. The log of 1, the log of any log of 1, the log of 1 is 0. In other words, log 1 is 0. So in other words, when x equal 1, x equal 1, y will equal 0. That is the x-intercept. Log function has an x-intercept, but for log, there is no y-intercept. No y-intercept meaning that this graph does not cross, does not touch does not tangent or cross the vertical axis, the y-axis or the y-intercept. So for log, there is no y-intercept, but the x-intercept occur at point 1, x equal 1, y equals 0. And then as you can see, figure 1.3, 1.34, okay, the shape of the log function, when we draw the graph, the shape of the log function is depend on, again, on the value of b. Whether b is greater than 1 or b between 0 and 1. When the b is greater than 1, as you can see here, the graph is rise from the left to right. Fungsi meningkat daripada kiri ke kanan. In other words, when the value of x, if the value of x increase, the value of y also increase. But if the value of x decrease, the value of y will also decrease and close to the close to the close to the close to the y-axis, close to the negative infinity. But when b is between 0 and 1, when b is between 0 and 1, what happened to the graph when b equal to 1, when b between 0 and 1, the graph will the graph of the graph will the graph fall from the left to right in the interval. This means that when x goes up, when the value of x increase, the value of y will decrease. Or when the value of x close to 0 decrease, what happened to y? The value of y will close to the positive infinity, or close to the close to the y-axis. That's the basic concept, the properties of the log when we draw the log. For example, let's say please refer to figure 1.35. Let's say we have the y equal to log 2x and y equal to log 1 over 2x. Okay, in this case, b is equal to 2 is greater than 1. In this case, the second one, b equal to 0.5, 1 over 2. That is between 0 and 1. As you can see here, when b is equal to, the graph is rise from the left to right, and when b is just 0.5, the graph is fall from the left to right. Okay, before that, okay, the intersection point. Okay, this is this intersection point. There is the log has the x-intercept. the x-intercept occur at point x equal 1, y equals 0. In other words, there is no y-intercept. The graph will not cross the x. There is no intersection at the y-axis. When you draw the graph, make sure there is no intersection. But the graph is also when get close to the x-axis, but not cross the y-axis. Tidak memintas paksi y. That's the characteristic of log. And then the rest one, okay, is about the relationship when we draw the exponential function and the log function, as you can see here. Okay, we can say that let's say we have two different equations. The first one is exponent, the second one is log. When we draw this graph, let's say y equal to bx and y equal to log bx. These two graphs are mirror. These two graphs we can say are mirror reflection of each other. And then we can draw, if we draw the symmetry line, we can have the y equal to bx is a mirror reflection of y equal to log bx. For example, let's say I have y equal to 2x and y equal to log 2x. The first one is exponent, base, the value of the base is 2. The second one is log, also with base equal to. When we draw this graph is a mirror reflection of each other, but with base 2, the same base of log and also for exponent. Okay, that's all about the graph, the description about the graph for the exponent. Same goes to y equal to, okay, before that, y equal to ex and y equal to ln x. As you can see that this ln x, this actually y equal to log e of x base e. This is y equal to ex. Okay, this is exponential with base e. The same base, but now but the first one is for log, the second one is for exponent. Okay, that's for the figure, how to draw the that's the information about the description about the graph of the graph for exponent and exponent and the log. In other words, we can conclude that given there are two equations, one is the exponent, the second one is a log. Assume that the b is equal, the base for the log and the exponent is equal. When we draw the graph are we can see that the graph can act as a mirror reflection of each other. Log is a mirror reflection of log of exponent, and exponent is also the mirror reflection of log, as you can see in figure 1.38 and 1.37. Okay, that's all about the log and about the exponent. Okay, the last one is about the last one about this topic is about the application. Of course, we need to apply this concept based on the based on the previous topic. I explained about the application of linear, application of quadratic, and then today I also show the application of the exponent. Now I will show you the application of log in terms of demand and supply. Okay, I think there are only two examples here. There are 2 or 3 examples. I will focus on this example. Given example for demand and supply, I hope you can try to analyze to answer the other example. Especially example 1.45 and example 1.26. But for today, I just explain the demand and supply based on example 1.44. Okay, please refer to this example. Okay, how to apply the log and exponent at the same time for this example. Okay, given in the question is about the okay, that is for a log and exponent. Yes, log and exponent. Okay, let's say given the demand function, we have a demand function. let's say we have a demand function. Given the demand function, it is a demand function where Q, okay, this demand function, Q equal to 18 minus 2 to the power of P. That is a demand function, Q in term of P. So the question is find demand function, find demand function P in term of Q. P in term of Q. P dalam sebutan Q. P equal to what Q, for example? Okay, given in the question, we have the demand function Q in term of P. Negative 2P. So 18 minus 2 to the power of P. So we need to find the demand function P in term of Q. P equal to what Q? So where is P? Okay, we have this P, this part, because this part, this has an P, negative 2P. We just arrange the equation. All the coefficient with P, we put in the left, and then the rest we just put at the right hand side of the equation. So in this case, we can write again 2P, 2 to the power of P. Okay, sorry, 2 to the power of P. 2 to the power of P equal to 18 minus 18 minus Q. 2 to the power of P equal to 18 minus 18 minus Q. Okay, now we still have the exponent 2 to the power of P. Now we need to bring down the P, bring the exponent part P, and then because we need to find at the end the equation must is in the form of P equal to what Q, right? We got P in term of Q. So in order to find P, we can take log for the whole exponent, for the whole equation. Let's say I choose log base E. Ln 2 to the power of P equal to ln 18 minus Q. So again, we have this power based on the rule of property of properties of log. This equal to P. We can write P as a multiplier of the equation. P times ln 2 equal to ln 18 minus Q. So P equal to ln 18 minus Q divided by ln 2. Okay, this is the answer. The demand equation P in term of Q. In other words, we just convert the original equation Q in term of P, but now we can apply the properties of log and exponent to convert or to transform the equation of demand from Q in term of P to P in term of Q. Okay, that's the answer, the demand function in term of Q. And then the question B, maybe we would like to find what is the price, what is P? Let's say, for example, find P, calculate P. Calculate P if Q equal to, let's say, 60 unit. What is P? What happened to P? So P equal to ln 18 minus 16 divided by ln 2. Okay, this is ln 20 divided by ln 2. Of course, please use your calculator. You need your scientific calculator in this case. So the answer is 4.32. That's how to find the P or Q, how to convert the demand equation, supply equation, total revenue, and so on, based on the to convert from the log to the exponent, and so on. So in this case, that means that for this topic, as a conclusion, we can apply. Basically, we have 4 equations here: linear, log, linear, quadratic, log, and exponent, and then we can apply this concept into the economic theory such as demand, cost theory, profit theory, and also we have a break-even point and so on. Okay, that's all for topic 1. Until this section, the application of log. I hope this topic this topic is very important. Based on this topic, and then, for the next week, we will move to the we continue to the second topic. It's about the mathematical economics, and then of course that in we need we can apply this concept of, especially the concept of log and exponent, when we learn about the topic 2, topic 3, and so on. So I think that's all for today. Okay, I think that's all for today, and then we have finished. We have complete this topic 1. Please do your exercise. Please refer to exercise for topic 1. I hope you please try to answer all the question. They are selected answer given in the question. But at the same time, if you want me to check your homework, please share with me via WhatsApp. Just convert your file into the PDF, and then I will check later. Okay, any question? I think that's all for today.
Doctor, next week class physical, right?
I think so. It's supposed to be physical lah. Like today lah, because for today I just have a emergency meeting at 2 o'clock. That's why I have not enough time to go to the MATEKONIAGA. But based on my timetable, next week is face to face. Otherwise, kalau ada perubahan, saya akan beritahu lah macam biasa tu ya.
Yep. Oh, sorry, Doctor. Midterm is end of May, right?
I think so. I hope. Because maybe end of May we also have Raya Haji, right?
Yes.
Rabu or Khamis, there are public holiday, meaning that there are no class. I try to set sama ada a week before Raya Haji or after Raya Haji. But I hope based on my planning, maybe kita akan ada mid exam at before Raya Haji, before maybe a 3rd week of May, right? Okay, any question?
Doctor, just to reconfirm, the midterm chapters are topic 1 until 3, or is it 1 until 4?
Based on performer 1 until 4. That's 1, 2, 3, and 4. But sometimes but topic number 4 is algebra matrix. Sometimes that topic basically is for quiz. But I will look like I will decide later whether for our mid is 1, 2, 3 or 1, 2, 3, 4.
Right. Okay.
Okay.
Thank you, Doctor.
Okay. I think that's all for today. Any other question? Okay, I think there's almost 2 o'clock. Okay, if there is no question, that's all for today. Thank you for your attention. Okay, see you next week at MATEKONIAGA. Next week we will I will explain about topic 2. I will share the file for topic 2 at the UKM folio. You can download as usual. Okay, for attendance, since this is online, no need to scan any QR code. Please just I will refer to the I will download the attendance list generated by automatically generated by these teams. Okay, for that I hope you can wait until I end this meeting. Okay, that's all for today. Assalamualaikum. Thank you. See you next week.
Thank you, Doctor.
Thank you, Doctor.
Thank you, sir.
Okay, bye.